and then achievements or outcomes. So, for an example, if you're not familiar with this whole empowerment and agency literature, you could think about fertilizer as a resource, right? It's a precondition, it's a resource, it's a thing. You have a bag of fertilizer, and you could think about decision making about the application of fertilizer as agency. So, does a woman have a bag of fertilizer? If she has a bag of fertilizer, does she get to take the decision about which plot it goes on, hers or her husband's? And then, of course, this affects outcomes because fertilizer affects the yield from the plot. It affects the income from the plot. And you can see how this can get a little circular too, because of course, income is a resource for the next piece of agency. But the idea here is that you can think through these different parts of agency and think about policies and programs to try to improve resources or agency or outcomes as part of women's empowerment. So these different pieces of empowerment, you can think through resources, agency, and achievement. And I'm going to be digging in really into this agency piece, this ability to define one's goals and act upon them. That's where I'm going to be focusing today. So we'll be seeing lots of ways to try to measure agency. All right. So I already kind of alluded to this, but one of the many reasons that we're interested in agency is it's often a target of interventions. It's a goal in and of itself for women to have agency, but it's often a target of interventions trying to improve women's outcomes as either the primary outcome or as a secondary outcome as a key mechanism. So for example, JPAL, the Poverty Action Lab that reviews and does evidence on randomized controlled trials, they have this nice review of 103 studies that are looking at enhancing women's agency in low and middle income countries. And they're all of these studies because it is such a target of interventions, whether it's the main outcome or as a mechanism for improving employment or reducing poverty or all these other things. So there's really an important question about how to measure women's agency. A lot of ink has been spilt and a lot of different indices have been created for measuring women's agency because I have an audience here that works on things like the Demographic and Health Survey and the Multiple Indicator Cluster Survey. Some of you may have seen some of these different measures, some of those indices, or worked with a variety of different ones. So there are all these guides, there are these reviews on how to measure women's agency, and there are different indices, some of which are contextually dependent. So for example, Women's Empowerment in Agricultural Index, WEAI, as you can infer from this, this is how you measure women's agency and empowerment in agriculture specifically. So it works well in rural populations, but it's not something that's going to make sense in an urban context. So agency may be context and domain dependent. You can think about different domains of agency. Do you have agency in terms of employment, in terms of finances, in terms of mobility? And there are many, many measures used to quantify agency, and that makes synthesizing evidence on what enhances women's agency a little challenging. And it's also kind of a pertinent question how to measure agency when you're trying to think about it as your outcome. So I am working on a number of projects in the region where agency is either a main outcome or a secondary outcome. And it's probably the outcome we spend the most time talking about how to measure in all of our outcomes, even when it's a secondary outcome, because it is very challenging to try to operationalize this concept effectively and to do it in a way that makes sense in different contexts. But you don't necessarily have a lot of time in your survey to cover agency. So you often need a short module for an impact evaluation or survey. And countries that are trying to collect data on empowerment and agency often want short modules. So for example, Tunisia, the country we're talking about today, is trying to include women's empowerment measures in the population census. So Tunisia is interested in trying to track empowerment measures. And when you're doing something like a census, you cannot have a really lengthy 3-hour questionnaire. You've got to get something pretty short in there. And so whether it's an impact evaluation, survey, census, there's really a question of how can we efficiently measure agency that I'm going to be speaking to. So what I'm doing today is I'm going to teach you a little machine learning. We're using machine learning to better measure agency, or we're trying to use machine learning. We'll see how we do, but I think We do okay. But we're asking, can we use machine learning to better decide how to measure agency? And this is very much building on Seema Jayachandran and colleagues' paper who they did this in India. They measured 209 married women's agency in 21 villages in rural areas in one district in one state. So a pretty specific location, which will be relevant to some of the comparisons I make to the results later. Pretty specific location. So they measure agency through semi-structured interviews and a battery of survey questions. So you're measuring it two ways. We've got the qualitative and the quantitative here, and you'll see the qual and the quant a lot. So we'll switch back and forth between them. And it's qualitative coding of semi-structured interviews used as the basis to generate a quantitative empowerment score from the qual. You create a quantitative score. The empowerment score is across 6 dimensions and averaged across dimensions. So we're like, okay, here's what the qualitative, which is kind of the gold standard for measuring empowerment, is qualitative data. You get a lot richer nuance, but of course you can only get it with a small sample. So we use this qualitative data like they did, and there's the quantitative score pulled out of that. And then what they did that we also do is use machine learning techniques to see which 5 survey questions best overall predict the qualitative score. So you've got the qualitative score, and then you've got a quantitative survey where you tried a bunch of different questions, and you're seeing how well, using machine learning techniques, you can figure out which questions would work best, which they then used in a subsequent study. And we're doing this for similar purposes to be like, what can we from this take away to use in different surveys? What questions that we've been trying in a bunch of contexts should we actually focus on? So we're undertaking similar research to what they did. So there's this like one key study that I'll talk about a lot, and I'll use this acronym JBC just for shorthand. So we're undertaking similar research in Tunisia. We include some additional survey questions and explore performance of existing modules that have been used in the country, as well as the same kinds of questions as the study in India. And we're comparing our results to the findings from India. We're looking a lot, you'll see some heterogeneity, like urban versus rural, what performs well within Tunisia. So just to turn this into some research questions, we're asking how different are the questions selected to measure women's agency out of this big set when we use the different machine learning methods in different contexts and using different subsets, because we use, for example, the demographic and health survey questions and see how they perform. And then, of course, we'll have a fun time nerding out about like which questions get selected, but an important question to ask is how much does this even matter, right? If we select slightly different questions, but they're just slightly different questions and they all predict agency just as well, it is kind of like not a very important exercise. But if they have a lot of variation in how well they actually predict agency, like if you pick the right 5 questions, you have twice the predictive power, then it's a worthwhile exercise. So I will try to convince you that in fact all this nerding out is indeed a reasonably worthwhile exercise. In fact, we can get a much smaller subset that performs relatively better if we use these machine learning techniques. I'll try to convince you that anyway. All right. Any questions so far? I'll just pause like for clarifications before we get into the data. Yes, that is coming up in methods. Hold that, yeah. And I will try, this was my first time using machine learning too, so I was learning as I was going. So I'll try to explain it well, but if any of you are machine learning experts and like want to chime in with a better explanation for something or tell me after how to explain it better, I appreciate that. I'm gonna give it a go though. All right, so data, as I said, we have this quantitative survey and this qualitative data. So quantitative survey, it has 89 different questions trying to measure agency. And then we have semi-structured qualitative interviews with the same women approximately 2 weeks apart. And we randomize like halfway through, we switch, half get the qual first, half get the quant first, then we switched. So we're asking these same women basically in a qualitative way, these semi-structured questions about their agency, and then we're asking them a battery of survey questions, and we're trying to kind of connect the two and use the qual to figure out what works best in the qual. Our sample was nationally representative, which is different than that past study, JBC study in India, because they were just looking at one location. We're trying to get nationally representative data because what I usually use and what the World Bank usually uses these measurements for is in nationally representative surveys or studies. So we're trying to see, like on a nationally representative way, what the best measures are. So we have a two-stage random stratified cluster sample. Our strata are Tunisia's 7 regions, and urban and rural, which is particularly pertinent because we oversampled to be able to compare urban and rural. Our sampling frame was all the sectors in Tunisia. A sector is the lowest administrative geography. There are 707 urban only, 1,088 rural only, and then 287 mixed sectors, which we split into their rural and urban parts. And so that creates sort of 2,369 what we call effective sectors once you split those ones that were mixed. And those are our primary sampling units. So we sampled 20 urban and 20 rural PSUs, primary sampling units, with the goal of being able to compare them. That's why we did that split. Probability proportional to size, where size is the household population. And we had 10 households per sector as our target, targeting 400 total. We did reasonably well, although some of these were the backup households, but we reached 387 with both the quantitative and qualitative data collection. And I have sample weights that I use throughout that account for the sample design and non-response at the cluster level. So we're assuming non-response at the cluster level is the people we do get represent those we didn't. All right, household selection. So we did a random walk within the sector. So we made maps with the sector borders, stuck a pin in a random GPS coordinate that was the random starting point. And then the field team, who were fabulous, went around and did this random walk, getting every 3rd household in rural areas and every 4th in urban areas. They made 3 attempts to reach those households, and they were trying to look specifically, we're looking at actually a somewhat narrow definition of a sample. We're looking at married women who have at least 1 child under 10, whose husband is co-resident. He doesn't have to be there at the time of survey, but home at least 1 day a week. And if there's more than 1 such woman, which was very rare, random selection. So even when we're talking about agency, I should acknowledge it's agency for a somewhat limited set of women, because married women agency can look very different than unmarried women. So that's another challenge that we didn't even try to tackle, is how do you measure agency for these very different groups of married versus unmarried. So we're just focusing on married women. All right, so here is, that's relatively readable, validation of our sample against nationally representative data, because as I said, we're trying to get a nationally representative sample. So we're comparing to, there was a 2023 multiple indicator cluster survey, a mix. And so the mix is there, and then the Women's Agency, WAM, is Women's Agency Measurement Project. So that's this one, that's what that horrible acronym is. So we're comparing and checking for significant differences on just some key demographics. So like number of kids, very similar. Household size, very similar, hooray. The one spot we had a little trouble was our sample has fewer employed women than the mix, specifically fewer wage worker women, not non-wage workers. And this is likely because, particularly because we had to visit twice to get the quant and the qual. Employed women are just harder to capture in surveys. And then we were basically trying to capture the same women twice. So that is a bit unfortunate. But otherwise, our sample is quite balanced. Education was still balanced, even though employment was not. This is a sample where we're talking about reasonably, like, the sort of modal person as a woman with less than secondary education, but there's a fair amount of secondary education, like a quarter, higher education around a quarter, relatively low illiteracy rates in Tunisia in this context. And as these are married women with kids under 10, as you'd expect, they're around 36, 37 years old. So this is mostly our samples validated against national representative data. Whether or not the employment piece ends up mattering when we're trying to measure women's agency, something you can weigh in on at the end. All right, so I'm going to tell you about the qualitative semi-structured interviews and show you a little bit of data from that, and then we're eventually going to get to those machine learning techniques. So qualitative semi-structured interviews followed a guide. There was a guide for all our fabulous field workers covering 6 domains. Education, which was about the kids' education, the decisions they made about that. Health, which was both their own health and family health decision-making. The women's mobility, both local and longer distances. Fertility decision-making, so childbearing. Finances, and employment. And so these are the same dimensions, similar guides to the other study in India. And these interviews, it lasted between 20 to 45 minutes, depending on how chatty people were and also, like, how many kids they had and things like that. They were recorded, they were transcribed, and they were coded in Deduce, which is a qualitative coding software. You were going to cover qualitative, quantitative, and machine learning today. You can see we had a good team to tackle all of these angles. So there's a hierarchical coding scheme within each domain, which I'm just going to show you what that looks like because otherwise it doesn't make a huge amount of sense. Okay, so this is part of our qualitative coding scheme sheet. With the hierarchical code, you were scoring people, which is a little bit of a weird thing to do with qual, is to turn it into quant, but we're scoring people with low agency to higher agency, right? So it's a scale, sometimes it's 1 to 4, sometimes it's 1 to 5. We recode everything to be on the same scale in the end, but we start the codes this way. So, and occasionally things could be missing for a variety of reasons. So we have these domains such as education, and sometimes we have subdomains. Sometimes though there's not a subdomain, there's just like healthcare. Or mobility, there's local versus long distance. So low agency is things like the husband decides alone about the kid's schooling, or mobility, the woman cannot go. So that's the low end of agency. And then we kind of work our way up. These are hierarchical. Maybe the husband decides, but talks to the wife first, or it's a joint decision, or she decides after consulting, or she decides alone is the most agentic measure here. Now, there's a lot of discussion to be had in the women's empowerment and agency literature. Are you actually more empowered if you decide something alone rather than jointly? So we can have a whole fun debate about that if you would like in the discussion. So I just wanted to acknowledge that, though, that you know it's tricky to turn these into hierarchical codes. Some of them I feel a little more confident about, like mobility, cannot go, must be accompanied, goes alone after obtaining permission, goes alone after informing, and she just can go alone without any of those things. So some of these where it's more clearly hierarchical, some of the others we hierarchically coded, but you could have a good debate about that. And then what came up in the field that happened sometimes too was with external factors sometimes came into play, which made it hard to code agency. So for example, there is only one hospital in this village or anywhere near it. And when you ask a woman, did she decide or did her husband decide which hospital to give birth at, she looks at you like, there's only one. What are you talking about? Okay, so that happens sometimes. And so we hemmed and hawed about this, and we're probably going to do some sensitivity analyses in future iterations. We decided things like this are low agency because she didn't get to take a decision because there was only one hospital, but is it the same as her husband? We can have a whole discussion about that too. So I acknowledge some limitations to this qualitative coding approach in advance, but hopefully you now understand kind of what we're talking about with these hierarchical codes. So we have these codes for 6 dimensions that we average into a single score. So we had the education, healthcare, and employment. There was just a single score for the dimension. You saw that with healthcare. Employment coding was necessarily different for those who do versus don't work. So if you don't work and it's your decision, you're empowered. If you do work and it's your decision, you're empowered, you have high agency. So that one was a little trickier to interpret. And then mobility, fertility, and finances had subdimensions. So we average the score across the subdimensions to get the dimension score. So for example, for finances, we average across decisions about her own money, her husband's household money, daily expenses, and big expenses. Those were the questions. And then for external factors, as I said, when there's no decision made due to external factors, only one school in the village, only one hospital, we were coded to the lowest agency. And the scores, sometimes they were 1 to 5. We rescaled to be 1 to 4, which, dividing down. And then we averaged the 6 dimensions, those 6 dimensions. And so this qualitative score at the end of all this is our kind of dependent variable. We're trying to explain what we think is a good measure, like qual gets a good measure of agency and empowerment. And we're trying to use these quantitative survey questions to predict that qual. So I'll just show you some of what the distribution looks like here for a minute before we get to the quant piece and the machine learning piece. So you can see, like, this is the qual score for health. There's some people with lower agency. There's some people with higher. There's variation. Education, there's not as much variation, but there's some. Employment, there's more variation. So there's varying degrees of variation across these dimensions, which may factor into what kind of questions end up getting picked up. And then these are the ones that had more subdomains that we average out. So you can see again, hooray, there's variation. We need variation to like do the analysis. This is good. But that sometimes like for mobility, there are people who are just like, yes, I can do it always and have a lot of agency. Whereas for some of the other ones, there's more of a like complete distribution. Mobility was kind of chunky. But this is good because we wanted to see variation. That's the variation we're trying to explain with the quant questions. So this is the outcome we actually use in all of our modeling. It's averaging across dimensions. It's a histogram. It has much more like continuous almost variation given the number of dimensions and subdomains. But you'll notice it has relatively normal distributions, relatively speaking. So we've got a nice outcome here to use for this qual score of women's agency. This average across dimensions is going to be our dependent variable. Hooray! Good outcome. All right. So the quantitative survey covered some demographics. And then all of these measures of empowerment. So these are quantitative survey questions trying to get at agency and empowerment. The same questions as the previous study in India were included with a teeny bit of adaptation, like, say in India it's rupees. When you ask a question about money, we switch to dinar, which is Tunisia's currency. And then swapping in like local major purchase examples that made sense in the context. So there was a tiny bit of adaptation of those. We also added a bunch of other questions. So there were 63 questions from the original set, and we added more from these, if you know the DHS and mix, the who has the final say on the following decisions questions. These are common. They're in the Demographic and Health Survey. We've used them in other local surveys, such as the Tunisia Labor Market Panel Survey, TLMPS. You will see this LMPS acronym come up a few times because we've done these studies also in Egypt and Jordan. So we have a bunch of empowerment questions that are locally adapted to the Middle East and North Africa region. So we pulled some of those in as well for the context of Tunisia. We included some self-efficacy measures, and then we added additional questions on agency around employment. In the original JBC study in India, they actually, during the qual field work, had not originally planned to look at employment as a dimension of agency and empowerment, but they realized, in fact, that it was very important. So they added it, but they didn't have the best quant survey questions for that. So we did some additional questions on agency around employment. So these are the quantitative survey questions, mostly measures of empowerment and a few demographics, that we're going to use to try to pick the best questions for predicting the qualitative measure. All right, so methods. Variable selection methods. The goal is to select 5 survey questions that best predict the qualitative score. There are 3 machine learning methods we use: lasso, stability selection; backward selection; variable selection using random forest. And I'm going to explain what each of these are in a second. And these are all machine learning and semi-structured interview MASI approaches that can be used for also, I want to point out, other social science concepts. So you may be interested in something other than empowerment, but things that basically lend themselves to open-ended questions, but where practical constraints require, like surveys, require closed-ended ones. You can use similar techniques. You can also, one thing you can do instead that's becoming more available is you can try to use large language models to handle open-ended questions. We do not do that, but we note that it's an alternative approach. So let me explain these 3 methods, and then I can dig into all our fun results. All right, backward selection. Name is one of the more intuitive ones, unlike some of those other acronyms. Backward selection using linear regression. Basically, we're iteratively removing the least important variable. It's a recursive feature elimination process. So basically, we make an index based on all 89 survey questions for the first go. And then we create indices from all possible combinations of k minus 1 variables. We drop 1 variable. So here's our initial index. Here are the versions with dropped 1 variable. And then we calculate the correlation from the regression of the qual score on the indices with the dropped one, all of those indices. And then we figure out which one, when excluded, leads to the smallest decrease or largest increase in the correlation coefficient, mostly smallest decrease. But when we drop one, which one has the smallest decrease in the correlation? So maybe the correlation with k variables is 0.52. All the k minus 1 indices have a correlation of 0.5, except one index has a correlation of 0.51. So you drop the question excluded from that index. And you just repeat this over and over until you end up with 5 questions. So you're just, you're dropping the worst performers over and over. Lasso stability selection. So lasso is least absolute shrinkage and selection operator. You might have heard of post-double selection lasso if you're econometricsy nerdy. I'm getting a few nods, but not very many. Okay, it's a way to pick variables. It's an extension of ordinary least squares. It penalizes and shrinks coefficients to 0 to avoid overfitting based on cross-validation. So the non-zero coefficients are the variables selected for the model. Everything else gets shrunk. And stability selection just iterates over different possible subsamples, so you're not driven by your sampling. So we basically draw a 50% subsample of the data, the lasso regression of the qual score on all the survey variables happens, noting which variables are selected, which are the non-zero coefficients, and we iterate 1,000 times. So it keeps like picking which ones have the non-zero coefficients over a whole bunch of repeating. And the 5 variables selected by the lasso model most frequently are our 5-question module, and we can average this. All right, last one, variable selection using random forest. So this one takes 2 slides because I have to explain what is a random forest first, which first requires explaining a decision tree. So this is an example of a decision tree, not the kind we're using, but I think it's more intuitive than what we're doing. A decision tree is like you're trying to classify something, and we're trying to classify environment. And you ask questions like there's a very
The first two methods seem to be maximizing, excuse me, association. That's not prediction.
right, those are selecting, and we're going to use the prediction to look at the performance.
Okay.
So they're maximizing. I mean, association is a form of prediction in that the ones with the strongest association are the best predictors. Is it working now?
Okay. I'll wait. I was just
Okay.
killing time.
Yes, thank you. You're taking advantage of every second because we have lots of people here. All right, so vsurf here, where I was somewhere. Okay, we're using random forests, and we're selecting based on the prediction performance, the out-of-bag error, and variable importance VI, which is the improvement in the model prediction when the variable's included. And you sort of select the number of forests to optimize the trade-offs between stability, which is the same variables being selected, and computing time. So like there's this algorithm to pick how many iterations you should do, and my algorithm told me 1,000. So I built 1,000 random forests. I rank variables by their variable importance, eliminate those with the low standard deviation in their importance, which is called the thresholding step. Standard deviations are correlated with, but better than average variable importance. And they build 1,000 random forests using the number 1 most, the 2 most, etc. important variables retained from the first step, average the 1,000 random forests, keep the one with the fewest variables with the out-of-bag error less than a cutoff. This is called the interpretation step. Build more random forests. Yet again, there are 3 phases here. Sequentially adding those variables from step 2 in the order of variable importance from step 1. So build and average 1,000 models. You can imagine my computer made some good whirring noises as we did these steps. And we keep variables if they decrease the out-of-bag error, the sort of fit or the error term kind of thing, by more than a threshold amount. This is called the prediction step. So we set the threshold to be close to yielding 5 variables. A variable is basically included if its mean out-of-bag error decrease is bigger than a threshold times its comparison to the following model. And we basically keep exactly 5 variables and refit the model for the final results. All right, so this is vsurf, the last of the methods. Basic idea is we're using random forests to pick variables for this one. I'm willing to take any clarifying questions. You can hold nerdy stuff. Yeah. 387. Mm-hmm. Yes, which is why we use vsurf, which is designed to handle high dimensional data, including when the variables are greater than the number of observations, which is not the case for us, but we have like 89 variables and 387 observations. So this is a method that's designed for not the huge N cases. it's set up to work well in these more modest or even more X than N cases. Yeah, so yep, so what your fold, yeah, so it gets called folds in machine learning, like yeah, you divide or you're kind of taking out 20% each time iteratively. So you have to have enough observations that that still works. So in the training phase, we have 80% of 387, which I can't do off the top of my head, but whatever that. Y- Yeah, so that is a little bit of the like you can use the step here that's the threshold amount is kind of if it increases it, it's based on the mean absolute difference between the errors. So it's not exactly like a p-value, but it's to keep it, it has to do well enough, like decrease the error enough. So it's of a similar mindset. Yeah. Any other clarifying questions before we get to the fun results? Oh, and I have to tell you this, you'll just see these in the results. So we do heterogeneity by question selection method. There are three methods. Different subsets of the questions from all of them, the previous India study, the labor market panel surveys, and the demographic health survey. And then heterogeneity by location within Tunisia, urban versus rural, and then Tunisia versus India. And then the most important question, as I said, like this is all very fun, but does it actually matter? So the correlation coefficient between the qual scores and the quant survey index, the averages, the five selected standardized variables, we'll see like how that performs, and that's the fit, and it may or may not matter. Sometimes it matters. Results. All right. So this is not as a little blurrier than I thought. All right. Well, I'll read some of them out. So these are using all the questions, the three different machine learning methods. These numbers are, this question was picked first across all three methods. Hooray, it's not super sensitive to method. This question was, would your husband be okay if you worked in an environment with mostly men? So very pertinent in the context of Middle East and North Africa. So these are the top five, 1, 2, 3, 4, 5 questions picked by Lasso. So they're questions about school fees for a relative, bank or savings account, buy things in the market without asking permission. And this is a sort of self-efficacy I can usually solve even challenging and complex tasks well. So those are all picked by the Lasso. And a somewhat similar set, number one's all the same, get picked by vsurf and backward selection. Lasso and backward selection tend to be more similar. The vsurf picks slightly different questions. 1 and 3 here overlap. It picks another question about work. Discussing the husband's relatives get picked up over here on the backward selection. Final say on buying personal clothes. And then this one is, can you withdraw money from your account? So like vsurf doesn't pick up, do you have an account, but it picks up, can you withdraw from the account? So there's a little bit where we're like, well, these are kind of similar questions. So how much is this going to end up mattering? But not super sensitive to method. And it's picked kind of an interesting set of questions in terms of their different dimensions, like household finances, employment, bank and savings. Like it's picking up a lot of very different things here, which we don't usually see in an empowerment index. Actually, you tend to see it more focused on one dimension. So where we're very different is compared to India. So the thing to notice here is like these are the questions they used in India, and these are our estimates using the same set of questions. So we pick up right this set of questions here, and a few overlap and a few methods, but mostly they were picking up a completely different set of questions. So this says we do cannot, it's not the same questions across at least country context, even when we're looking at the same set of questions. But we also have a similar result for that in rural versus urban, even within Tunisia. So this is a very much a context matters kind of story. So the urban ones are the ones you saw mostly a lot in the main national estimates. Would your husband be okay if you worked in an environment with mostly men? Comes out up top. And then rural has a different, really like only sometimes just one of them overlap. A rural has a different set, but they're kind of variations on the same types of questions. Rather than would your husband be okay, would you be okay working in an environment with mostly men? So this is where it's like related concepts are clearly relevant in urban and rural areas. They may just be somewhere different on a sort of scale of empowerment. So that was an interesting difference between rural versus urban. And then these you may recognize from a lot of the DHS questions. So here's the labor market panel survey, which includes these DHS questions and the DHS questions. And it's a much smaller subset we're choosing from here. So there's not as much difference in terms of what questions get asked, but it includes that same employment question, and then a bunch of like just different iterations of which decision really ends up mattering if you were trying to narrow the set. DHS only has a finite. So now the important question, does this actually? All right. It's very interesting. We had a very fun, nerdy time looking at all those questions and thinking about like, oh, how are they related? But this is where we have the correlation coefficient with the qual score for different methods and then subsets of questions or locations like urban sample, rural sample. This bottom is from the India paper. So remember, they were working in one, I can't remember what it's called, sector or what it was, district, 21 villages in one district in one state. And so they got pretty good, like 0.5 correlation between their 5 questions that their method selected and the qual score. And we, in a national sample, don't get quite as much correlation, but still, between point, like these two are 0.4, that's like 0.33 with the V-surf. The methods don't make a huge amount of difference, but we're getting less correlation in a nationally represented sample than they got in a narrower sample. And we do see this even with rural versus urban, right? When you narrow to a rural sample, you get better performance, you get a stronger correlation, probably because empowerment really does look different across contexts. So this is an inherently challenging thing. And so the urban, it really depends a little bit on which measure, does or doesn't perform as well. There's not a big difference if we go back up here and look at that subset of questions that came from their paper versus ours. So adding those additional, whatever it was, 26 questions, didn't hugely increase our power, even though we selected different questions. But if we had just used their questions, so this India index is if we just use their questions on the Tunisian sample, those perform actually the worst. The labor market panel surveys perform reasonably well for a shorter set, and the DHSs are pretty mediocre. So like the DHS questions and the India questions that are from very different contexts do not seem to predict qual well, whereas the ones from other countries in the Middle East and North Africa do a bit better, but you can select higher performing ones, particularly when you narrow to more of an urban or rural specific context. Just to show you that this is actually a worthwhile effort too, this is the correlation of the qual scores from our overall sample, like these 3 are from our sample, these lines, and 5 random questions from out of the 89. So this is the correlation, this is the distribution over 1,000 iterations of our different, like 1,000 iterations of 5 random questions. You get kind of some correlation because they are measuring agency, but you can do much better with machine learning. So machine learning does get you a better question set than trying to kind of pick either randomly or some other way. So that bit is true, but it really varies on how it performs across different contexts. So I think I'm doing okay on time because we're at the summary and conclusions. Summary, which 5 questions? We use quant, qual, and machine learning to try to identify a 5-question module of women's empowerment questions. Question selections were not super sensitive to method, lasso, V-surf, backward selection. There's some variation, but that did not seem to be the driving difference. Question selection was sensitive to location. India versus Tunisia, even with the same set of questions. Rural versus urban. Although they're similar, it's like, is it your concern about working with men or your husband's concern about working with men? Similar, but distinct. And of course, these different subsets of questions yielded a different 5-question survey. That part was not surprising, inherent to the question design. So to summarize the performance kind of from that slide of the 5-question modules, we find correlations around like 0.4 with all the questions in the full sample. The additional questions, so we had 89 relative to the India paper, we only get slightly better performance if we just narrow to their set of 63. We can still get like 0.25 to 0.29. It's not that big of a difference. So adding those additional questions does not make a huge difference. But the DHS, that correlation is about almost just half, and similar to India questions when used in Tunisia. So my interpretation of this is it's pretty challenging, problematic, applying all these agency measures broadly across contexts, which of course creates comparability issues if you do different measures, but we can talk about that in the discussion. The labor market panel surveys, which are a little more contextualized but regional, do a bit appreciably better than the DHS questions and the questions selected in India. And then urban and rural, although there's a bit wider of a range across methods, you can get better fit with narrower samples. So it may be, for example, when you're doing a randomized controlled trial in a particular location, you can get a pretty good fit, but for national surveys, it is tricky. And so its comparison, the paper that in India was rural in one district in one state had a slightly stronger correlation. So conclusions. You can use machine learning techniques to create a short quantitative module that measures qualitatively initially measured, but agency reasonably well. You can do much better than 5 random variables. You can use these machine learning techniques to pick which questions. And we agreed a little bit with their recommendation. We prefer the lasso a bit for its sophistication versus backward selection, but also transparency in terms of that. The measures, though, do not necessarily perform well across contexts. So we were having a whole discussion this morning. Does it mean for every study you want to do about empowerment, you have to do this kind of exercise? But contextualized questions may also perform well enough. We see this with the labor market panel surveys. So one of our lingering questions is it feasible and cost effective to do this type of adaptive work? Like, should you be doing it when you're trying to measure agency before starting a study? And can it be made cheaper, for example, with AI? So I'll conclude with this next steps, and you can weigh in on this too. One of the things we're going to do next, or maybe it'll be a terrible idea and you'll tell me not to do it, but is use AI and different levels of AI to see if it can do some of the qual coding. So we have to use AI to translate before all the other steps, but we can tell AI to use our coding scheme and our questions to make an index and see how it does compared to our qualitative coders. We can also tell AI to develop its own coding scheme to make the index a dependent variable. We can tell AI to do the whole analysis and just be like, here's the quant, here's the qual, select the quant questions and see, does it use machine learning techniques? I don't even know, it's a whole black box. Or we can just give it the qual and say, come up with 5 closed-ended questions based on the qual. We'd have nothing to validate, but I'd be very curious what it comes up with. So this is what we're thinking about doing next. We just got the transcripts fully, carefully de-identified so we can actually do this, having had them coded previously, but not fully de-identified. So this will be coming up in a future version. Thank you for bearing with this very nerdy topic, and I look forward to questions and discussion. All right.
Thank you. Great talk.
Thank
You haven't, well, in the qualitative summary score, the
Mhm.
dependent variable, you average across the different domains,
Yeah.
education, labor force, but that means you treat them all equally,
Yeah.
which is an empirical assumption that seems very fishy, especially comparing, say, rural and urban people. But you also haven't said a lot about how well anything predicts. So are we talking about distinctions in methods between like amazing predictors versus just so, or are they all mediocre and we're just splitting hairs, or how well does any of this predict?
Great question. Yes, domains weighted equally. So one of the other slides I didn't make for time, but was we need to do a bunch of sensitivity analyses to things like what if we do a factor analysis that tries to correlate the different domains and sees what agency actually is sort of empirically, or what if we just focus on a few of the domains, how different are the results? So very well taken in terms of that. That is coming up in the sensitivity analysis. In terms of how well things predict, I mean, this may be one of those things where it's like different disciplines use the word predict differently. So here our questions are predicting, I mean, a correlation coefficient, right, of 0.4 or 0.5 is a reasonable predictive power, but does it predict other things like um, whether or not the kids go to school is an unanswered question, right? And so that's something we could do in terms of validation, is predicting not just the qual score, but other things that are associated with agency. So well taken on that other question. Yes.
How do you know you're measuring empowerment? Period. And
What a great question.
also, why do you think that it would be better to have AI do it? Because aren't isn't AI going to be like less innovative and just using the past knowledge to apply whatever we used to do to it because it's been trained on old stuff? So why would you think that'd be better?
Yes. So, how do we know we're measuring it? That's a great question. I mean, all these things, like all of the inputs, get labeled empowerment. Like these are all empowerment, efficacy. All of these kinds of concepts are conceptually empowerment. And the qual score is like this idea of agency, right? She gets to actualize her decision. So, does she actually get to take the decision on finances? These are aligned with the concept of empowerment, but it's one of those, like in factor analysis, you're trying to measure a latent variable and you just label it empowerment. In the end, fundamentally, you're doing that with any index. Um, an interesting question that we didn't do, but we could have done, was we could have asked women, what are the decisions that matter to you? And then interviewed them about those. But that would have made it very hard to compare, like create comparable coding. So your point is well taken. And then whether AI is going to be innovative, one of our, I think we're looking more for, is AI a cost effective way to do this? But I don't think it's going to be an innovative way to do this because it was very like labor intensive. They're all these qual coders. They're fabulous. They're wonderful. They did a lot of work. It took them a lot of time. This was a huge qual sample, by the way. Like people thought we were crazy to be doing this the qual sample size. The qual people are nodding like, yes, you're crazy. Right? So replicating this across context is very challenging, but maybe you could do the qual interviews and then have AI do the coding. Like it's an open question of could it be or cost effective. But we are not evangelizing for AI. It was just like, what are our other options? And people are talking about this, and we want to. Our answer may be it works very poorly. So when I report back, I'm very willing to have that answer. We just got the de-identified transcripts. Haven't done it yet. Other question.
Can you go back to your slide for the results of comparing the three models? Okay, comparing the three models, and then can you do it comparing to India? The next slide where it also compares to India.
Yes, this is using the same set of questions. So necessarily, the first question is not in the India set, for example.
Okay, so I'm interested in the V surf and how it's different
Yes, it is
from.
different.
And in the India, did you find the India sample find the V surf was different
Yes,
as
it was
well?
more different as well. So, like, if you look at the lasso and the backward selection, they have more like 214, 124 have more overlap.
Okay,
So it was not, the method seems to be inherently more
different.
different.
Okay, so I have a
Yes.
hypothesis for that.
Yes, good.
When I've used random forest, the value of random forest, which is built on the model based recursive partitioning, which is your decision tree, the value is it's not modeling the main effect. It's splitting and splitting and splitting. And its value is to model higher order interactions. And so what you're capturing here probably is that your variables are interacting with some other variables. And so it's interacting. And so those variables are coming through as an important variable because they're interacting with the other important variables. It's really hard to interpret
Oh, yes.
the value. What our team has done, and I don't know how you could do this, is you could force
hmm
a main effect
Mm-hmm.
as the first break,
Mm-hmm.
and then see what happens. But then you're not. Then you can't see. Then you could see what interacts after that first break. Um, like what variables come out as interacting with that first main effect, for example, or if it comes out, I don't know. Anyway, we could talk afterwards. But the thing is that it's an interaction. That's why it's different. It's not a main effect.
Yes, and I think it comes through like in some of there was one of the questions, like, can you withdraw? The Visa picks the can you withdraw, which is really an interaction with do you have the bank account in the first place? So we do see a bit of that. I don't, yeah, we could think about interacting with the Visa. We could also think about interacting in the other models and see if then they pick more like what the research does. No, you don't want interaction. This is true. Yeah. Hmm. Hmm. All the vsurf. Yeah. Hmm. As the trees go. Yeah. Hmm. 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 Where it is. Yeah. Yeah. Mm. Mm. See what the structure is. Hmm. How it partitions. Hmm. That would be very interesting. Thank you. Took a note of that
Uh,
for the next iteration.
I would have so many comments, philosophical or methodological, but one of the things I'm wondering is how were the interviewers trained to ask these questions? Do you trust that the answers were neither lie nor self-deception? And whether you could apply some of these methods on an objective, measurable thing, see which questions are most likely to elicit true answer, not necessarily a predictive answer.
Yes, there are many. Okay, there are many parts embedded in that. So I'll start with the qualitative teams. I think you're talking about the qualitative teams training, right? So the quantitative team was trained as well, but it's a little more straightforward because it's like yes or no or like Likert scale questions. So the qual team had a bunch of training. We had an international expert in qualitative methods. We had a local Tunisian expert in qualitative methods. We worked with a survey firm that did both the quant and qual and hired folks for that. We did do quality control on who did the qual out of the quant and like out of the people who were trained. So we put a fair amount of effort into that. We had folks reviewing the transcripts from very early to make sure that they were asking correctly. We did have occasional issues with like there are occasionally missings because they missed one of the questions, but it was pretty well standardized with the transcript review, which happened on the office level, the Tunisian trainer, and the international expert level. Fortunately, the international expert spoke Arabic, so she could even check that process. So we feel reasonably good about the qualitative interviews being as they should be in terms of data quality. Whether or not people are answering these questions, honestly, there's a whole literature on social desirability bias in responding to these questions. Given the thing that I will say is, given the qual descriptives, I feel relatively good that like we're seeing variation. People are not always saying, of course I can do what I want, right? There are people who are saying, no, I didn't get to make a decision about my employment. That was my husband's decision. So the variation gives me hope, but like truth, it's really hard. Yeah, yeah, yeah. But so the variation makes me optimistic, and the process makes me optimistic. But measurement error, always a problem.
All right. We have a question. We have a question from online.
Okay.
Do you engage with some Islamic feminist through thought to inform your approach to agency, performativity, and the feminist subject? I'm thinking specifically about Saba Mahmood's Politics of Piety, where she puts forth a nuanced definition of agency that does not see submission to patriarchal norms as inherently disempowering. It could be a useful text for interpreting the heterogeneity of expressions of agency in different contexts.
Yes, that is a great question. I took note of that so I can go back and read because I'm not familiar with Mahmoud's particular work on that. But I think the sort of question of what is agency and who gets to define it is kind of inherent with what that comment is talking about. And it is very true that so we have one of the members of our team is Tunisian, but there were a lot of Western perspectives necessarily represented, and it was the World Bank's kind of idea. So there are certainly market economist kind of perspectives coming in here in terms of what does agency look like. And one of the ways that we wrangled with these tensions was, as employment's not up here, but like, we considered it agentic to not want to work because that's what you wanted and say that you got to take that decision. We consider that high agency as well as wanting to work and taking that decision. So we tried to leave some space for women to define in their local context what agency should look like for them if it was wanting to work or not wanting to work and how that kind of played out. But I think it's a very legitimate critique that this is despite being feminist in one sense in trying to look at this issue of women's agency, there are some real limitations to how we went about that. So I appreciate that comment.
All right. Well, welcome me in thanking Dr. Krafft for coming to give this awesome talk today. Thank you so much.